Hello my dear students, welcome to our program for chemistry third secondary stage. Chemistry is very important for our life. Chemistry is a very nice thing to study.
Catch this word now, chemistry, that we need to start to work. I think you are ready now. What about to go? Let's go. My dear, hydrolysis of the salt. Hydrolysis here it means how can the salt decompose. To know that we must make this experiment. What is the different solution?
Here we have different solution here, many types of this solution to see what? To see hydrogenation of these salts. So here, this is the experiment. What will happen here?
We have a different salts. As a beginning, aluminum chloride, potassium carbonate, and different for the sodium phosphate, potassium phosphate, and different one. Now, all of them depending on the two main factors, positive and negative. Do you think all of them it has a positive?
No, they have what? They have positive ion of all of them.
Good. The other section of the salt must be negative ion. This agent added to each one. What you see?
Here, the first one, AlCl3 or aluminum chloride, change into red. So here, the second one, K2CO3, change into blue. And the third one, NH4Cl, change into pink color, or it is near from red color. So the other one?
Good. This it means the other one has a different agent to change its color. Do you think why? This is back to
what? Back to the positive ion of salt here and negative ion. The positive ion, if that comes out from a strong acid or a strong base here, the positive one comes out from the positive or strong base. So here change into blue. But if I have the other one or the negative radical that contains negative part or change into red, it comes out from strong acid.
Acidity and basicity. Look at this. We have an experiment to tell me about this. Place a solution of sodium carbonate, ammonium chloride, and ammonium ethionate and sodium chloride. This is in 4 different test tubes. After that,
sodium carbonate solution, alkaline solution.
Effect on litmus paper. Turn it to blue. Now, do you think why?
Yes, because we have Na2CO3. It's what? It's dissociate in the water, giving what? Giving carbonic acid. So the carbonic acid, it's what? It's a weak acid. Sodium ions and hydroxide ions. So here the sodium hydroxide, it's what?
Is not formed because it's a strong electrolyte. It's good to say that sodium is the strongest one. Now, look at this. Completely carbonic acid is formed due to the reaction between
a hydrogen ion,
forming ionization of the water. All of them to tell me what happened inside the reaction of the water. Look at this.
Here we have the carbonate ions in the solution to give the carbonic acid. It's a weak acid, almost not ionized. Any weak acid, remember this, not almost ionized. Why? Because it is weak, because it makes reversible reaction here. So the weak acid almost not ionized, and
that therefore the concentration of the hydrogen ion decreases in the solution, causing the disturbance in the equilibrium of the water. Disturbance here, it means there is no equilibrium, there is no good ionization. Don't forget, strong, it means completely ionized. Weak, it means
we have no disturbance in the equilibrium in water. So here we have no ionization or no complete ionization takes place.
It's good. My dear, according to Lachatelier, you remember Lachatelier principle in order to attention as a state of equilibrium. After that,
another time we have other molecules of water are ionized too. The compensate the decreasing in hydrogen ions.
Good to catch it. Look at this. Hydroxide ion are formed, accumulated and increased in where?
In the concentration to level greater than the concentration of hydrogen ion, giving a pH more than 7.
It's good. It means you have hydrogen ions. It means you have basic oxides, basic solution. It's good to catch it. Look, my dear, 7 here, it means more. It means it's a basic solution. Also, we have
Sodium carbonate solution is alkaline solution.
stop here. Alkaline. It means the solution pH
Equal more than 7. So here the sodium carbonate, sodium, it comes out from what? From the strong base. And we have the carbonate, it's formed what? Formed the weak acid, formed from weak acid, that's called the carbonic acid as we see before. So the solution, it's alkaline.
Good. Due to the strongest electrolyte, sodium. It's good to say that. My dear, hydrolysis of the ammonium chloride, salt derived weak alkali and the strong acid, water and ammonium chloride are ionized as a following. Look at this and concentrate. Ammonium chloride. See and look.
Here we have the equation 2H2O. It's reversible reaction into H2H positive plus 2OH negative. So here this is the first one about water liquid. And we have the salt here, ammonium chloride. Ammonium chloride decomposed into
By the water decomposed directly for the reversible reaction to NH4OH, ammonium hydroxide, and H positive plus Cl negative. This is ionized, but I think this completely ionized. Do you think that?
no, we have in H4OH, it is not completely ionized.
So, back to this. Ammonium chloride has an acidic effect on litmus paper. It means it change it into
Red color
this, not all. This red back to the ion of
of acid,
good, which is
Cl negative or chloride ion.
it's good. Don't forget this color to acid. Also, I say why. Look at this.
Here we have NH3 and HCl. NH3 here, it is a solution of what? Of the ammonium. And here we have NH3, it is ammonia solution in water. And we have HCl. If you add both of them to each other, forming some white fumes or white what? White clouds of ammonium chloride here. Why? Because here we have reaction between them. What is the reaction?
The reaction is not start well, but I see the concentrated HCl closed to the ammonia. Now, both you see the vapor from HCl. Also, the ammonia here is a gas. We'll try to make a combination between them. Look at this. When they are combined together, will form a new compound. It means NH4O, NH4Cl. It means what?
It means neutralization reaction that's happened here between the NH3 as a compound or as a base, and we have here the acids.
The neutralization not yet here. This is ions. Ionization. Look, this cloud of ammonium chloride, it means this reaction is a direct combination reaction. So NH3 with HCl equal NH4Cl clouds, white fumes, white clouds that move around. It means you have new acidic compound, which is
NH4Cl.
good. It means acidic one because Cl is strongest acid. Good and great. This reaction stay for long time and the cloud start to move and form it many times. It means the ionization here completely or not completely?
This is not completely.
I think why? Because it's what reaction?
This is reversible reaction.
Good, my dear. Don't forget the reaction which you studied before for reversible and irreversible back to the ionization. Look at the cloud. The cloud here increase. It means the ammonia gas combined with hydrochloric acid, concentrated one. So the result directly NH4 positive to the negative one. But I think we have another experiment.
We have another experiment here. It's about what? About heat energy and water.
This ionization is the acid react with a ceramic boiling stone. We want to see this is ionization also or hasn't. Do you catch it?
Yes, we have here, this is a complete reaction that happened here between the acid and chips of what? Of the ceramic. So we have, this is the reaction that happened here, and many times it's kept to crystals here, and what? And can discharge it here between them.
The reaction here will present 150 milli of the ammonium solution and HCl about 30%. This solution, it's back to the ceramic. Ceramic, it means calcium carbonate. You have a salt. So the calcium carbonate also can be ionized. To see this ionization, make a boil and see. Do you think what happened for this salt?
So this salt, it makes ions that form what? That form this reaction, and the crystals of the salt here that's precipitate on what? On the wall of this beaker. What here? What happened here?
Directly we say this crystals is a basic one. To know that it's basic, we back to the scale because we have a calcium. Calcium stronger than carbonate, so you have a salt solution. What about the other?
Here we have number one about NH4Cl. It's because what? Because NH4Cl or ammonium chloride dissociates in water, giving ammonium hydroxide, NH4OH, and hydrogen ions and chloride ions. So the hydrochloric acid is not formed. Why?
This is back to the ionization completely here between the ammonium chloride. HCl is not enough. Look at this. It's a strong electrolyte, completely ionized, H positive and Cl negative. The presence of chlorine ion doesn't affect in the water equilibrium. What else?
Here, ammonia ions react with hydroxyl ions, resulting from what? Resulting from the ionization of water. So here we have the OH negative ion react with ammonia ions in H4, forming what? Forming a base. This base is weak base that called ammonium hydroxide.
Ionization of the water all time give ammonium hydroxide. This it means weak electrolytes. It means incomplete ionization. Look, is not enough for us. Therefore,
the concentration of hydroxyl ion, it decreases in the solution, causing what? Causing the disturbance here in the equilibrium of water.
Now, according to Le Chatelier, don't forget this principle, Le Chatelier principle, in order to attention to the state of equilibrium. We arrive to mean one, equilibrium during ionization. Now,
another time, another molecule of water are ionized into compensate the decrease in hydroxyl ions. Why? Due to Le Chatelier principle also. So here, this is the ions of water that decrease in hydroxyl ions.
So compensate here, it means hydroxyl ion replaced the amount of the water that ionized. Also, we can say hydrogen ion are formed, accumulated and increased. Increased for
concentration.
It's good. Look to the level of the greater than the concentration of the hydroxide ion, giving pH. Do you think what it's now?
So here the pH is less than 7. So thus the ammonium chloride solution is what? Is acidic.
We back again to forest 1. Acidic. It's back to pH 7. It means
this is acidic 1 less than 7. So here the less than 7 is acid, equal 7 is neutral, and more than 7 is basic.
Now, hydrolysis of the sodium chloride. Sodium chloride in ACl, positive and negative. Salt is derived from the strong alkali and strong acid. Both of them are stronger. Do you think what happened during this?
Here we have the sodium chloride solution has neutral effect on litmus paper and make complete ionization inside water.
pH equals 7. Why? Because we work through
the equilibrium or pH value.
good neutral solution. Neutral because NaCl dissociates in the water, giving sodium ion, hydroxide ion, hydrogen ion, and chlorine ion. Now try to make a compound between them.
So the electrolysis of NaCl. Here we have the test tube filled with NaCl solution. Let's go to see this one. Here we have the ions here that start to make dissociation inside water molecules. Why? The water, it makes what? It makes the ionization by the electric energy. So here the ionization here of water OH negative and H positive. So after that we have the salt solution that try to move slowly from the tube outside to the water.
I collected the gas now. These gases, I want to know its type. This gas, hydrogen? No, Cl2. Look at this. Cl2, it means let's insert a small the air weak and see what happened during this. When you insert this rod of the air inside the tube, concentrate and see. The reaction here start to be changed or not. Look and concentrate. You see the effect? The color here change it.
Yes.
Back to what? Back to
the reaction between the ions.
good. Now ionization is happened for this reaction. All time I add this a piece of the iron for different solution as you see and see what happened. You have an important compound.
Here we have iron chloride 3. We have the iron chloride 3. It means a new compound that formed from this reaction.
You have ionization. Look at this. From this, both hydrochloric acid and the sodium hydroxide are strong electrolytes and completely ionized. Both are moved together for parallel way. Now,
Here therefore the hydrogen ions and the hydroxyl ions. We remember this. We have the hydrogen ion and the hydroxyl ion in all solutions that found or that contains the ionization of any compound. So resulting from the ionization of water remains constant and the solution will be neutral. What's meant by neutral?
again we said that it's a neutral pH equals 7 all time. In a neutral solution, you have pH equals 7. Also, from this previous observation, we conclude that
Hydrolysis of salt, it is the read ions and of what? Of the ions of salt with water, giving the acid and base from which the salt is derived. Why? Because here the salt is formed of ion from or radical of acid and another radical of base. So here the ionization that found between them or the ionization of any salt solution in water based on the ionization of these ions of acid and base from which the salt is derived.
this not all. We have hydrolysis of the salt in the opposite to the neutralization process. All time we ask what is meant by neutralization. It's reaction
Between the acid and base
to be.
to form salt and water.
It's good to say that this is neutralization. The acidic or basic property of the salt solution depending upon the respective what?
Respective strengths of both the acid and the alkali. So here the acid and alkali are formed solution of the salt in water.
To be neutral one that we need. Look, we have solubility product. It's a good title, solubility. Sure, we know that this is after ionization. catch the definition for each one. Look,
Here, the solubility product, when the solute is added to a certain quantity of the soluble solvent at specified what? Specified amount or volume or specified temperature of the solute, dissolve in further solute is added to it. Also,
dissolves. Why? Because you have a temperature in the solute, but this dissolution process doesn't proceed to endless. Why we say that? This is
back to reach to the state where the solution is saturated. Saturated, it means what? It means this is full of the salt and with the solute, and the solution becomes unable to dissolve more. We cannot dissolve more amount or additional amount of the salt to the solution. Which type of solution? Saturated solution.
This saturated solution is very important because the solute, its constant volume and temperature. Any solute added to this stage will precipitate. Be sure, more solute, it means more precipitation in the solution because it's a saturated one. After that,
the dynamic equilibrium that takes place, or dynamic equilibrium state between the solid substance and the solution, is established here. Why? Because here dissociation of the water, dissociation of the salt in water into many ions.
Because you have a solid one. It means now if you have here a graph and I try to make equilibrium, but during this digging you have one side is higher and the other is lower. Do you think you have equilibrium?
No, here we have no equilibrium. Because what?
Because there is no balance between the ionization of the two salts. But from time to time, when we return back the forward or backward reaction, we arrive to that. Look at reversible reaction.
So the forward reaction, it makes what? It makes this one. The direction of this forward reaction and the reversible reaction, forming the ions or forming the compound, and ionization in the second one. So dynamic equilibrium takes place.
Dynamic here, we need a solid. The solid substance can be completely ionized. No observable change. It means there is no equilibrium. But during the gases which we studied before, you have two important one. For the first, heat the tube and add drops of any substance. What happened?
Here we have a reversible one. And the second one, we have the tube that makes this matter or this type of energy that comes out from what? From the outside to inside. And we have the example of reaction here.
You have iodine and hydrogen. This is inside the closed system. It means this closed system depending on the energy only. Now, let's see the reaction. Iodine is react with hydrogen and form
2HI, hydrogen iodide, forming this compound. And this compound try to make ionization also in the closed system, forming what? Forming ions of hydrogen and iodide.
Oh, this can happen. Sure, we know that because this is reversible one. When you stay a time, you find the amount of H2 and I2 increased, but increase the two arrive to equilibrium. Equation is
H2 plus I2 give us 2HI, and we have the hydrogen molecule or hydrogen iodide that's decomposed into
H and H. It means hydrogen molecule. All of them depending on closed system. It means depending on the change in energy, the motion of the molecules inside the system, back and go, back and back. This it means a dynamic equilibrium. What would happen
to this reaction if the lid on the top of or open this glass jar? Here we have the ions and the molecules of compound that try to move out. Hydrogen gas, it moved out. So we have no equilibrium here after opening this jar.
We say that back to open the system. The system is changed from the closed to opened one, from energy only to energy and matter. Now, the experiment for this case, phase change can also reach to equilibrium. The life must arrive to
equilibrium.
Now, what happened during this reaction?
Here we have the liquid of bromine. So the bromine 1 or element, no observable change here in this closed system. So in the system is in dynamic equilibrium between the bromine in gaseous state and it's found in liquid state. So the dynamic equilibrium takes place in a closed system. But if you open the closed system,
if you open the change H state, H system, now dynamic back to closed system. I like it, wonderful. Catch this now.
In this case, the law of mass action can be applied. Do you know the mass action law? So the dissolution of the springly soluble lead bromide in water. So here springly soluble lead bromide in water, it means it is not dissolved in water easily. It's given by this equation.
Look at the equation. The equation about lead bromide, look at this PP, Br2, due in two sides, reversible one, directly we have BP negative 2 plus 2Br. This reaction need closed system to be in dynamic equilibrium. Look, my dear, for this.
Here, the Kc, it means the equilibrium constant here of PP negative 2 power of negative 2 times Br power of 2 divide PP Br its power of 2. Why? Because here the power of each one is reversible to what, or refers to what? Refers to the number of molecules or number of moles in each one of them.
I want to arrive to equilibrium, so concentration of the product per concentration of reactants. After that, don't forget the power, because it means the number in the forward of the compound or the element. This is per to find the other one for the reactants. Now, KSP, constant equilibrium for solubility, equal concentration PB power negative 2 by BR by power 2. Now, you have negative 2 for the power for the first and second one is 2. This it means the important number for solubility, because we depend on the molecules, the number of the molecules, because I work through dynamic equilibrium closed system. Catch and look.
Here we have another example about this. We have the degree of solubility of silver chloride AgCl. It's equal what? 0.10 power of negative 5 mole per liter. Calculate the solubility to produce or the solubility product of what? Of AgCl. What is the answer here?
Solution. The solution, it's worked as these steps. As a beginning, you have a compound AgCl will be decomposed directly into Ag positive plus Cl negative. Now, what you have?
Here, the KSP, equilibrium constant of solubility, equal the Ag positive plus Cl negative ions. The total of these ions equal what?
This will equal KSP 10 power negative 5 by 10 power negative 5. Directly we have a good answer, which is
10 power of negative 10.
Good. Now we have KSP constant equilibrium for solubility.
Dear friends, I hope to enjoy your time with us. It's a very interesting part about our curriculum today. Till we meet again, thank you and goodbye everybody.
Good. And I want to say start well, because we need to work all time. The work is very important. No chemistry without working. See you and goodbye.